So next, we're going to look at a different measure of spread called the standard deviation. And so we're going to be measuring deviation or difference from the mean. And so the first thing we're going to need here is the mean of these scores. And the mean of these scores turns out to be 5. And so what we're going to do here is look at our data and then the deviation. In other words, the difference between the data and the mean. How far each of my data values is from the mean. So for this data set here, let's see, we got 0, 0, 0, 0, 0, 10, 10, 10, 10, 10. So the deviation here is data minus mean is -5. And I think you can trust me that all these other zeros are going to be the same. And then for the 10, 10 minus 5 is 10 minus 5 is also 5, positive 5, and so on down the line. Now, we want to find some measure similar to sort of the average of our deviations. The problem is that if we added these all up, they'd add up to 0. And so we need to do something else, and there's a couple approaches that we could use. It turns out the one that makes the most sense is to square the deviations. There's various reasons for this, but most simply, it will definitely make the values positive. So -5 squared is 25, 25, 25, 25, 25, 25, 25, 25, and in this particular case, it's very easy to calculate, too. And so we find all of our deviations there. So now we're going to find the sum of those squared deviations. So we're going to add all these up. So we're going to add all these up. Let's see here, I'm adding up 25 10 times, right? So that ends up being 250. So we're going to find the sum of the squared deviations. Actually, I'm going to write that down here, 250. And then I'm going to divide it by not how many, not by how many, okay. Well, what we divide by depends upon whether our data was coming from a sample, in other words, from a sampling of all of the data, or whether it was representing the whole population. So if it's the population, then we divide by n, the number of data. If it's the sample, then we divide by n minus 1, 1 less than the total number of data. In this case, this is representing the entire section's scores, and so we're going to divide by n. We're going to divide by we're going to divide by n. We're going to divide by the 10 scores, and we're going to get 25. Now, at this point, we have something called variance, or more specifically, the population variance, since this was for the entire population. The standard deviation is the square root of the variance. So it's the square root of 25. The square root of 25 is 5. And so the standard deviation of this data set is 5 units. Now, for comparison, let's look at all of our other data scores. When all of our scores are the same, the deviation is going to be 0. The data set we just looked at had a deviation of 5. In this case, all the scores are much closer to the mean, and so the standard deviation is going to be smaller. In this case, even though we had the same mean and median and range as our data set B, the standard deviation here is much smaller because most of the data is very close to the mean, and we only have a few values that are further out. So if the data is very spread out, we have a big standard deviation. If the data is closer together, we have a small standard deviation.